Alright, first off we're gonna analyze this square right here to get the coordinates for the Morse circle. So this 27 is going to the right, while 18 MPa is going down. Now, because it's going down, it's going clockwise. So that's going to be positive, and then the 27 is positive because it's going to the right. So our x is 27, 18. Now, 45 is going down, so that's going to be negative, and then we know from this arrow right here that it's going counterclockwise, so that's also going to be negative. To find the average, I added negative 45 with 27 divided by 2. That got me to negative 9, which I can use for, this should say center, is negative 9 comma 0. So I have all the values I need to start my circle. As you can see, I plotted my circle right here, and then drew the lines down to find the triangles needed to find the radius. So this is 36 wide and 18 tall, so I brought this triangle over here, and I found the actual radius. This is not the radius, which is 40.25, and that means that the maximum shear stress is going to be 40.25. Using this same triangle, I can also find the angle right here. So over here I did opposite over adjacent because it's tan, and then inverse tan of 18 over 36 equals 2 theta pi, which is gonna get me 26.57. So now I know the radius, or I know the values of AC and the origin with C, so I can calculate my maximum principal and minimum principal stresses. So I did OC, which is the distance from here to here, and it's negative 9, plus AC. So the distance of AC is going to be just the same one, is the same as the radius. So that's going to be negative 9 plus 40.25, which equals 31.25. And then I use the same values except make it negative for the minimum, which is going to be negative 49.25. Finally, so I know that this is going to be rotated over to here, and I know the value of here. I know the value of this. I also know that this whole thing equals 2 theta, so theta equals 75, and because that's just the square, I need to multiply 75 by 2 so that I can get 150. So now I know this is 150, I know this is 40.25, I know that this is 109.75, and I have the value of this right here, which is 26.57, but I don't have the value of here, which is what I need. So this whole line is equal to 180, so I can take 150 and 26.57, add them together, and subtract 180 by the new value. So that's what I did. I get phi is equal to 3.5. This angle right here is equal to 3.5. And then using this angle, I can find my normal stress and shear stress, which I just took the same triangle and brought it over here. 40.25 times sine 3.5 is equal to the normal stress, which equals 2.46 megapascals. And then 40.25 cosine 3.5 is equal to the shear stress, and that equals 40.17.